Hi guys, good morning. So already 10, yes, 10:06 a.m. But two of you, I think, two of you are still. Mm, okay, so I think we can. I should turn on. Okay, so okay, so yeah, I think I assume you guys can hear me. So now we are already in week 10, 23rd of 23rd of August. We're in week 10. So this week we will cover this chapter 9, which should be covered last week, software architecture and system architecture. But this chapter is not, um, I don't think this is a complicated chapter. These two, software architecture and system architecture. Okay, so we will proceed with this chapter as last week we already covered chapter 7 and chapter 8, which is specifying and specifying operation and control. So this week, today, this morning, we will move to this one. No, this one should be later. This one too. Chapter. Where's the chapter? And this one, not this one. Obviously, oh, I haven't opened. Wait, this one. Okay, so we will learn about system architecture and software architecture. So this one in this chapter, there are only I think two, if I'm mistaken, two diagram. But this chapter is not like the previous chapter where we learn about diagram. So this chapter and the next, which is chapter 10, is you will learn about the concept of system architecture and software architecture. Actually, I'm not sure if you have this in your as a subject or as a course, because this one last time during my time we take this system architecture as a course. That means this is a standalone subject, not under one chapter. But I think it's okay if they include this in your as one of the chapter in your in this course. So this one is system architecture and software architecture. So in this chapter we will learn what is the concept of we will learn we will learn what is the concept of software architecture, partitioning into subsystem. So partitioning is like dividing into part. So dividing into part for subsystem, layering, and MVC, software design architecture. So MVC is stand for move or model visual model view controller. So we look into this, the part of MVC, model view controller, or what it is for, and software design architecture, as well as the 3-layer and 4-layer of software architecture. Okay, so so first, as the course line just now, we will see what is the concept or what is software architecture. Wang Zisheng. I think, where is this guy? Wang Zisheng. He already missed my class. I'm not sure why. I think he should check his attendance, because if I think you know this, if you I 80% of your attendance, you will be barred from exam. So maybe someone need to find this guy, Wang Zisheng. Yeah, Wang Zisheng. So let's proceed with our lecture. So software architecture. So what is software architecture? So before we go to that slide, so software architecture is actually a conceptual model that defines the structure behavior of the system. Okay, so as you can see here, the software architecture is a description of the subsystem and components of a software system and the relationship between them. So as you can see here, I highlighted this point. So description of the subsystem and components. You all, I assume you know what is subsystem. So subsystem in one whole system, subsystem is a part of your whole system. It's like one whole system, and then you have that sub in your system. So, and the components of a software and the relationship between them. So the keyword is subsystem and components. So it is the relationship between these two, subsystem and the components. So this is the concept or the basic definition of software architecture. So subsystem and components are typically specified in different views to show the relevant functional and non-functional properties of a system. The software architecture of a system is an artifact. It is the result of the software design activity. So let me explain the point here. So subsystem and components in one whole system, they have their own function to perform. Either it is functional or non-functional properties. So this subsystem and components will combine to form one complete system. Okay, so that's the definition of software architecture. And this guy here, as you see, there's a reference here, Bushman et al. 1996. This guy is quite famous in this field, in our field, because I remember I read his paper a lot. No, it's not only for research. In this OOAD, this guy is quite famous. I'm not sure who is him, but he contribute a lot of his idea into the OOAD field. So here, architectural aspect of software design. So what is architectural aspect of software design? Like I already explained just now, what is a software architect? So software architect undertake the following activities. So software architect will cover this 1, 2, 3, 4, 5 point here, but it is not limited to this, but here they only listed 5. So subsystem and major components are identified. I already explained just now what is subsystem and components. So they need to identify what is the subsystem and the major components to perform the function, like functional or non-functional. And then any inherent concurrency is identified. So we already learned what is inherence and concurrency. Concurrency is like they're occurring together. It's like, yeah, they're occurring together. So inherent concurrency, and subsystem are allocated to processor. Subsystem are allocated to processor. A data management strategy is selected, and a strategy and standard for HCI are chosen. So HCI is actually, it is a domain, another domain in computer science, which is they have. Do you guys HCI? Did you guys have any HCI subject, or have anyone of you learn? Yeah, HCI is one. Yeah, course. Sorry. So yeah, HCI is actually a course or subject. Same with the software architect and system architect should be a course, but I think they want to combine it here. So HCI is urban computer interaction. So in HCI, uh, HCI, I think you should know because you have this is your current subject, current course in this semester. I learned this one like 5 years ago, but this one is more to like UI things, UI UX things, UI UX thing. So a strategy and standard for HCI interaction are chosen. So since said that you already have that course this sem for HCI, you should know what is high fidelity and low fidelity, right? So guys, what is high fidelity and low fidelity? High fi or low fi? Nathan, this guy. Wong Zisheng, good morning. Hi. So what is high fidelity and low fidelity for HCI? Rachel, what is high fidelity and low fidelity? And these guys too. Alvin, what is high fi and low fidelity? Already week 10, so I assume you should know already. Huh? High and low quality? No. High fidelity in low and low fidelity in. Guys, I still remember what I learned 5 years ago, 2016. High fidelity and low fidelity is actually a type of what? Jeremiah, what is low fidelity and high fidelity? Robinson, what is high fidelity? So it's okay. High fidelity and low fidelity is actually in HCI. The thing that I remember, high fidelity and low fidelity is like the prototype, prototype of our interface. So I assume you know what is interface. Interface is what we see, the front end of the system. For example, this is my interface here for Google Google Meet. So so this one is my interface. So before the designer design this UI, they need to design a low fidelity first. So low fidelity is like the scratch of this interface, whereas high fidelity is the prototype that closest to this interface. So low fidelity comes first before high fidelity. So low fidelity is like the scratch, and high fidelity is the most closest prototype to the real interface. So that is low and high fidelity. So if I'm not mistaken, in this subject HCI, you will learn a lot of drawing. It's not a lot of drawing. You need designing of course you will learn concept, but you will learn about designing of the interface, the UI. And for your information, there are a job specifically only for designing. We call it as what? UI designer. Yeah, designer only to design specifically for interface in HCI. So maybe some of you think HCI is easy, but no, HCI is not that easy because to HCI is very important because to attract people to your web, actually there's things like expert designer for UI. If you go to see, for example, Apple website, Apple is it? Yeah, Apple website, you can see they have a very good UI because they have expert for that. Every button in the UI, every button in the interface that we see, it is after so many designs. So HCI is interesting, and HCI is quite, yeah, for me HCI is quite interesting. UI, UX, user interface, and user design. Okay, so you guys should know SCI better than me because that's your current subject. So here is subsystem. So we go back to this light subsystem, like I brief you guys this now, and I think you know what is subsystem. Like I said, subsystem is a part of your whole system. So here, subsystem. A subsystem typically groups together elements of the system that share the same common properties. So subsystem here, like I said, it is a part of your whole system, like sub. You know the term here, sub. So it is a subsystem that usually they have or they share the same properties. Some properties or common properties can be their attribute or can be their method, method or function that they share. So that one is subsystem. Okay, an object-oriented subsystem encapsulates a coherent set of responsibility in order to ensure that it has integrity and it can be maintained. So here, subsystem encapsulate. So if you guys remember what is encapsulate, let me recap for you. Encapsulate is like grouping together. So subsystem is grouping to like they are grouping together the same element that have same common properties. Okay, at least they share some of their common properties. Okay, that is subsystem. And then each subsystem provides service to other subsystem, and there are two different style of communication that make this possible, which is client server and peer to peer. So here, each subsystem, that means every single and each of the subsystem have their own function. That means they need to perform their service or function for other subsystem. So that means they are related to each other. So there are two different types, which we will see here in this chapter, which is client server, client server, and peer-to-peer communication. So before we go, let me explain to you. So client server is a communication where we have the client. Client is a entity. Client is an entity that will send requests to the server. Okay, so client is the entity that will send a request to the server, while server is the entity that will respond to the request by the client. So this one we call as one-way communication. Client will send request and server will respond to the request. While peer-to-peer is a relationship where they have entity or where subsystem can act as a client or as a server. That means it's two-way communication. So for example, we have entity A, it can request, oh it, no, it can send request to entity B and entity B can send request to entity A. That's mean either way, two-way of communication different with client server. Client server only one way. That's mean client can only be client, server can be server, while peer-to-peer, they can be client or server. So we will see later what is this. Okay, so there are two types here. They are trying to, no, this slide here trying to, they said that have two types, which is client, server, and peer-to-peer communication. Okay. By the way, guys, do you know what is server? Do you know what is server? Server, what is server? Because last week I asked my student programming class about database. Yeah, a computer meant storage of a service. It's a computer actually, but yes, what is the yes? Server is where we keep. Yes, I think you know what is server, so I don't think I need to explain. So here, this is the definition, or it's not definition. This is the concept. Man storage for a service. It is a computer. It is a part of our computer that has its own function. A database, yes, where we store our data. We call it as a database. It can be cloud or it can be physical database. A central database. This one is the same like this one. Okay, so that is server. So the subsystem, again, the subsystem here, mm, the subdivision of an information system into subsystem has the following advantage. So this is the, of course, there are more advantage of subsystem. So it produce smaller unit of development. It produce smaller units of development. So I think you know these two. No, I shouldn't make an assumption anymore. So in a project, let's say we are working as a, we take ourselves here as a programmer. So in a project, of course, in a project, we have a team. So in this team, we have a project leader, which is usually a lead for programmer. And then we have us as a programmer. So for example, we want to develop student intranet, your system, student intranet or staff intranet. So in this staff or student intranet, they will break into smaller component or smaller module. Yeah, usually it will be divided based on module. So they will be divided into smaller module or smaller, no, it's not smaller module. It will be divided into modules or smaller or subsystem. So they will divide the system into smaller units. So it's easier to develop. So from this one subsystem, let's say team A develop subsystem A. Team B will develop subsystem B or module B. So they will be divided into smaller unit. Usually this is the common practice wherever you go. If you, again, as a programmer, this is the common practice that you will do. Okay, smaller unit for development or this, yeah, development part. And it helps to maximize reuse at the component level. That's mean it will utilize the component, it will utilize the component level. That's mean they will use whatever they have, utilize the component level. And here it helps the developer to cope with complexity. So to cope with complexity, not only for subsystem. I remember last few, no, last few week, we study something that related to sub. So whatever we divide is not only subsystem, it can be a diagram. So whatever that uh, includes sub, it can tackle this complexity, because if we design, if we do not break into the subsystem or sub module, then it will be hard. There will be we call it as uh, conflict. Yeah, conflict. There will be conflict for that system. So we need to divide into subsystem to avoid complexity. So complexity can be tackled or can be solved using subsystem or subunit, and improve maintainability. So as we already learned in our chapter 3 or chapter 4, I don't remember, there's a phase to maintain. So like what you already learned, the F5, which is planning, analysis, designing, implementation, and maintenance. So maintenance is always the last part of our development. Maintenance, that means we already deliver the project or the system to the client or to the user. So maintain is always the part of our cycle. SDLC, software development life cycle. Yeah, maintainability. So it will help in the maintainability part. So how it will help in the maintainability part is by, okay, let's say we have a system that we have this subsystem. No, of course we have a subsystem. So, and let's say they have a bug or error. Bug is like, yeah, bug is like an error. So of course there's few type of bugs. So let's say there's one bug. So in that system we have one bug. So with subsystem we can find the root cause. We can troubleshoot the bug easily, and we can maintain the system easily. That means we doesn't need to touch other part. Instead, we know where is the specific root of the bug. So it will improve the maintainability. It will be easier to do the maintenance. So again, there's a job for this. We call it as a support. Usually depends on Depends on company, but usually the team that will do the maintenance is the support team. Okay, there's no such term like perfect system. Of course, there will be bug or improvement or enhancement. Okay, here it adds portability. Portability here I already I'm not sure if you can see this, but portability is the ability of software to be transferred from one machine or system to another. So portability to operating to multiple operating system. That means the transfer from one machine to another. So for example, we have this system we already deploy. Deploy is deploy is a process where we transfer into a server. So for example, we have this system A, or system or application A that we already deploy into a server, and then we want to change this, or we want to deploy into another server. So using subsystem, it will help in the portability. That means the process of transferring from one machine or system to another. So from one server to another. Okay, so that is portability. Okay. So any question before I move on to this one? Just now I said client and server and peer to peer. Any question? Actually, this chapter is mostly like I said, there won't be like our previous chapter, many diagram, but only few diagram to tell us what is the concept or to explain what is the concept. So for your case, because you guys are online class, so I can foresee to your exam. I'm not sure. Maybe your exam, your final exam, because this subject your final exam, I can foresee or I can predict your exam will be in final exam as well. So maybe some of you think you don't have to memorize any of this, but again, at least try to capture the concept. Last time during my study, if I find a chapter like this where I need to do a lot of reading, because in exam cannot, it's not an open book. It's not an open book exam. So I like this kind of chapter where I need to memorize stuff or memorize things. So maybe some of you don't like reading, so you don't think this is important. If even though if you think this is not important, but again, let me remind you, just capture whatever the concept is. If you don't want to remember everything, of course you need to remember everything. But yeah, you guys are different time from me. It's not, my time is not an open book. You guys, you can Google everything. Okay, so yeah, that's my point. So here, style of communication between subsystems. So the thing just one, the thing I said just now is client server and peer to peer. So here we have an example. Here we have subsystem A, B, C, and D. So we will look into this one first, client and server, subsystem A and subsystem B. So this one is our client and this one is our subsystem. So here, the the server subsystem does not depend on the client subsystem and it is not affected by the change to the client interface. That's mean here, these two subsystem, client and server relationship, yeah, client and server relationship, they doesn't dependent on each other. That's mean whatever happened to the interface of, for example, in subsystem B, the server, it won't affect this client subsystem A, or whatever happen here in subsystem A, it won't affect subsystem B. That's mean they are independent. Okay, they are independent. They are not affected each other. That one for client A, that one is for that one is for that one is for client and server relationship. It is a one-way communication. Like I said, client will only send requests and server will only respond to the request, and they are not dependent on each other. Okay, different with peer to peer. This peer to peer, like I explained just now, based on our previous slide, peer to peer is a different relationship like client and server, which peer subsystem C can send request to subsystem D, and subsystem D can request to subsystem C. That means they can be either way. They can be one of them. They can be the client and they can be the server. And this one for peer to peer, they are related. That means here each peer subsystem depends on each peer subsystem depends on the other and each is affected by change on the other interface. So I think the point here is straightforward, which explain that this subsystem will affect subsystem D and this subsystem will affect subsystem C. Okay, they are dependent on each other, different with this one, independent, and this one is dependent. So whatever change will affect other of them. Okay, that one is client and server and peer to peer. So now we will see what is client server communication for subsystem. So client server communication requires the client to know the interface of the server subsystem, but the communication is only in one direction. Okay, this one, the one that I meant just now, in one direction. For client server, that means client can only send request, while server can only respond to the request. That one is client server function. So it is one direction, one way of communication. Client only client, server is only server. They cannot perform other function. And the client subsystem requests service from the server subsystem and not vice versa. That means the client subsystem can only send the request to the server and not vice versa. So it is client is like official game server. Peer-to-peer is like people to make their own server. So here first, game server. Yes, client is like official game server. That means we play. Okay, client like official game server. Yeah, not only official game server. It can be any server where we as the user or we as the gamer, we send the request to the server of the developer of the game. And peer-to-peer is like people make their own server. Yes, it can be applied to this concept. Oh yeah, we can create our own server. So that is peer-to-peer. Yeah, P2P is like both side a server and the client. Yes, this is peer-to-peer or P2P. That means either way, they can be the client and they can be the server. Okay, that one is peer-to-peer. But here, client unofficial game server. This one, the one I said one-way communication. This one is two-way communication. But is there such thing like one-way communication or is that my term? One direction. Don't write in your answer one-way communication. It's one direction. That means, yeah, one direction already explained what is one direction. So the client subsystem requests service from the server subsystem and not vice versa. Okay, it's one-way direction. It is different with peer-to-peer communication, or if you Google, they said P2P, peer-to-peer communication. So peer-to-peer communication requires each subsystem to know the interface of other, thus coupling them more tightly. So, um, wait, the communication is two-way since either peer subsystem may request service from another. So this one, oh yeah, correct my term, two-way communication. So you can say two-way or one-way communication. So peer-to-peer, they need to know what is the other interface of the, in this term, the couple subsystem. And then the communication for P2P or peer-to-peer is two-way communication. That means they can be the entity where request, or they can be the entity who respond to the request. Okay, so that is the concept of uh, peer-to-peer or client server communication. Okay. So Daniel, do you have any question? Daniel, do you? Oh, okay. I think the concept is quite easy, right? So that is peer-to-peer and client server relationship. So I think not only for this subject, for computer science, the concept of peer-to-peer and client server, is basic. So of course we need to know. Okay. So layering and partitioning. So layering, from the term, I think you know what is layering and partitioning. Like I already explained, partitioning is like we split, we divide into part. So here, two general approach to the division of a software into subsystem. The first one is layering and partitioning. So what is layering? So layering, it is a different subsystem usually represent different level of abstraction. So abstraction, what's abstraction? Okay, so abstraction, as we already study, abstraction is like we only show the the essential information. So we only show the essential information and hiding the rest of the information. So that one is layering. And then the second one is partitioning. So partitioning usually means that each subsystem focus on a different aspect of the functionality of the system as a whole system or one system. So usually they will combine this both approach, layering and partitioning, in one system. That means, or for one system, they not only focus or they not only choose one. Usually they will combine approach. Both approach are often used together on one system. So here we go to the first one, layering and partitioning. Two types of layered architecture. So we have a closed and we have an open. Okay, we have a closed and open layered architecture. So closed architecture minimize dependencies between the layers and reduce the impact of a change to the interface of any one layer. So we will see what is the concept based on the diagram for this one. And then open layered architecture produce more compact code. The service is of all lower level. The service of all lower level layers can be accessed directly by any layer above them without the need of extra program code. That means this one, they only we will see later what is clause and architecture. By the way, this is the explanation for clause and architecture. So in the next slide, so this is the explanation based on the previous slide just now I said. So this one is closed and this one is open architecture. So message may only be sent to the adjacent lower layer. So for example here, we have layer n. Layer n for closed architecture, it can only go to the one layer one layer below it. So layer n minus 1. So for example, here is layer, for example, here we have layer 5. They can only send to layer 4. Layer 4 can only send to layer 3. Layer 3 can only send to 2. 2 can only send to 1. That is the concept for closed architecture. Okay, closed architecture. While open architecture is like free. They can send from layer 5 to layer 3 maybe, layer 5 to layer 2 or layer 5 to layer 1. It's like free free passing free passing of message, so message can be sent to any lower layer. That one is for open, that one is for open architecture. That means they can send to any layer. For closed, they can only send to one lower layer or the adjacent lower layer. Okay, so that is the concept. And this one is the explanation just now. So for closed architecture, it can minimize the dependencies between the layer and reduce the impact. That's mean for closed architecture, this one, it will reduce the impact. So whatever happen here, it won't really affect other layer. Maybe it will only affect one layer below because you can see the process here in only to one adjacent layer. So different with open layer, produce more compact code, the service of all lower level layer can be accessed. So this will break the encapsulation of the layer. So encapsulation, like already explained, encapsulation is like we grouping or binding together. So this open architecture will break the encapsulation of the layer. Okay, so no more encapsulation for this one. It's like binding of attribute, schematic of layer architecture. Okay, so that one is for closed and open architecture. So here we have, okay, so this one, OSI. Do you study networking? Yeah, networking. Do you have a course that related to networking? So you should know what is OSI, right? Have in diploma. Oh, so for degree, you haven't studied OSI? So OSI is actually open system intercommunication. It's okay. I just want to ask. Open system intercommunication. So, sorry. So this one actually, mm, actually, this one is a layer. So this one we call as OSI. So OSI stand for Open System Intercommunication. So what is the function of OSI? Actually, it is not stated here in this lecture, but OCI is used to communicate over a network. Communicate over a network. So this kind of study usually will go to the networking because I study this one too because I'm software engineering and then I took this course networking. But actually for networking, there's one program specifically for networking. So this is like the foot to the networking student. So here, as you can see, there are 7 layers: application, presentation, session, transport, network, data link, and physical. So like I said, OSI stand for Open System Intercommunication. So this OCI is, the function of this OCI is to communicate over a network. Okay, communicate over a network. So again, uh, of course, you guys need to know this. This is not, this is usually for computers, for networking student, but you need to know what is the, because each of the layer here have their own, function. Okay, layer 7, which is application, provide miscellaneous protocol for common activities. So this part here, for 7 of this layer, I leave this slide for you guys to read. So basically, the function of OSI is to communicate over a network. Okay, in the exam, I think, because I don't think for your open, because your guys is open book exam, so I don't think they will ask you directly to list down what is the 7 layer of OSI model. I don't think they will ask you in your exam. If it is a closed book exam, I think it is possible for them to ask you stat the 7 layer and each of the function for each of the layer. So since your guys is open book, so I don't think they will ask you such that easy question. So maybe they will give you a situation. So from that situation, you need to understand which layer is the communication. So this slide, I leave this one for you guys to read on your own because I think the explanation here is straightforward. I already read this one. There's no rocket science term here. I think it's all easy. So yeah, you guys read this on your own, okay? But Like I already explained, OSI, the function is to communicate over a network. So each of the layer has their own function, or yeah, they have their own function for OSI. Okay, so that one is OSI. So layering and partitioning. Partitioning applying a layered architecture. So there are, it's not issue, there are concern that need to be addressed. So the first one is maintaining the stability of the interface of each layer. So like I said, each layer has have their own function. So it is important to maintain the stability of the interface. So they won't interfere or they won't disturb other layer interface. The second one is the construction of other system using some of the lower layers. Some, not some. The construction of the other system using some of the lower layers. And then variation in the appropriate level of granularity of subsystem. So granularity is a level of details. So variation in the appropriate level of details for subsystem. So for further subdivision of complex layers, so they need to look into subdivision that have the complex layers. So this is one of the issue. It's not issue, concern for partitioning and layering. So performance reduction due to a close layered application. So close layered architecture is the one I explained just now. Close layered, okay? So performance reduction due to a close layered architecture. So what is the affected? It's not affected, but yeah, what is the affected layer due to one layer that has problem? It has issue. Okay, it will affect another layer. This is due to the closed layer architecture. So I already explained what is closed layer architecture. Okay, now we move to this chapter. We move to this slide, layering and partitioning. So this is an example of simple layered architecture. So there are three level or three layer, which is application, data formatting, and data management. Okay, this one is application of class, data formatting class, and data management library class. So we will see we will see these three layer. So layering and partitioning, developing and layered architecture. So this is to develop a layered architecture. So define the criteria which application will be grouped into layers. This one is encapsulation. Okay, define the criteria which the application will be grouped into layers. So a commonly used criteria is level of abstraction from the hardware. So this one is the encapsulation process. So a commonly used criterion is level of abstraction. That's mean the definition of encapsulation is grouping together into same same common attribute. So here the common use criteria is level of abstraction. So like I already mentioned just now, abstraction is like we only show what is the common information. So common here in this case, it will be grouped by common attribute. It's not information, attribute. Okay, from the hardware. And then determine the number of layer. Name the layers and assign functionality to them. So specify the service for each layer. So like I said, each layer has their own function. So you need to specify each of the layer and refine the layering by this process. That means we repeat this one until for step number one until step number 4. Okay. And then specify interface for each layer. So because if you go back to the OSI model, for each layer, they have each function and each function, they have their own interface. So they have different interface for 7 layer. Specify the structure of each layer. This might involve partitioning within the layer. Partitioning, like I explained, I think 2 times already today, partitioning is the like dividing into parts. So maybe they will dividing the anything in that layer into parts, and then specify the communication between adjacent layer. This assume that a closed layer architecture is intended. So adjacent layer is one layer, one level of layer below. So this one is assume the closed layer architecture. So closed layer architecture, that means they can only send message or interact to one layer below of them. Okay, reduce the coupling between adjacent layers. This effectively means each layer should be strongly encapsulated. So the function of this one, reduce the coupling between adjacent layers, is actually to reduce if there's any to reduce the impact, that will affect another layer. So this effectively means that each layer should be strongly encapsulated. So that means each of the layer should be um, less dependent, to other layer. So strongly encapsulated. Okay, that means they will of course receive some impact, but it won't it won't give them major impact to their layer. Okay, so that's the function to reduce the coupling. So any question? Please do not throw sausage pizza. I don't understand. Do you mean that you shouldn't forget what you already learned? Is that what you're trying to say, Rachel? Oh, 7. Yeah. Okay. Please do not throw. Okay then. By the way, last time when I was a study, I like this kind of chapter because, like I said, in my study, it is a closed book exam. That means we cannot bring book to the exam hall. So if for any sub course, we call it as a course, right? So any course that need to read and memorize a lot of things. So for sure, that's that's my foot. For example, the one that I said just now, the OSI model, that one is in a networking subject. So I studied that one too in my master, but it one is advanced networking, if I'm not mistaken. Yeah, I remember all. I remember everything. It's not I remember, but that one you shouldn't do. Yeah, I want to say this. There's a difference between girl and boy. Girl, for us, we memorize. It's not that we memorize things. It's easy for us to memorize. I do not know why. But for guys, I think you guys are good in mathematics. Okay, I'm not that good in mathematics, so I'm good with this kind of subject. Every subject that need to memorize, for example, the one HCI just now, human computer interaction. If I'm not mistaken, for that subject, I got A minus. And networking advanced also, yeah, I'm not that smart. Only at A minus. I'm not sure, but I think girls, me myself, I love to read, so I can memorize things. I can, if for example, if this lecture not 32 pages, right? If we go to, I'm not sure the practice for current student, but last time back in 2016, we will print this lecture note and we will bring into class, because during my time we don't open laptop during the lecture, only for lecture. We won't open the laptop, yeah, because the lecture hall is quite big, right? Hundred of people in there. So lecture student, yes, who press. So we are not allowed to, sometimes not, we're not allowed, but yeah, we usually print this lecture note. So I can memorize. I think most of the subject that I got A or A minus is because I have a good, I won't say that I have a good memory, but yeah, I memorize things. So if they ask us, I can explain. I can give the exact point here, like this one. But the thing that is sometimes last time I only memorize. I don't understand the concept. So when I go to work, sometimes I need to study back the concept. Okay, so you guys shouldn't do that. Study for your knowledge, not for your exam. Don't be like me. Okay. So here, okay, let's go back to this chapter. F 1930. Guys, can we have like 5 minute break? 11 4 minutes. Okay, thank you. Okay. Hi. So I read your message here. Kelvin Shak, I'm not good at theory. So Kelvin Shak, you must be good in mathematics, right? I think those who are not good in theory, most of you guys should be good in mathematics. I think so because a boy student should be better in maths compared to girls. So Kelvin Shak, what are you good at? So problem solving. So you must be good at programming because programming or algorithm. So any subject that involve maths or algorithm. For my master, even for my master, just because I do mixed mode, right? For my master, I can get all A, but one B. The B will be on the algorithm part, B plus. Okay, so let's move to this lecture note. It is obvious. Oh, by the way, I want to share something again with you guys before we slide. We move to our slide. You know, because this is a, I'm not sure it's a maths or what, but I think is not, girl don't really do well in maths. I'm one of them. Last time when I was, because I went to a matriculation program after my SPM. So SPM is 17, matriculation program is like 1 year program before degree, so 18 years old. So last time when I went to matriculation program, I studied physics, chemistry, mathematics, computer science. So I took these four subjects. So I took these four subjects: mathematics, chemistry, physics, computer science. So in the matriculation, we have this one program. Here in TAR also we have this program that known as advisor advisee. So in matriculation we have uh so in matriculation we have this mentor mentee session, mentor mentee program. Okay, so I have a mentor who is a lecturer in mathematics. So in matriculation program, I'm not smart as them. So but in matriculation program, most of the student who perform well during the SPM, that's mean most of them who get A's, 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 straight A's is like nothing in matriculation. So most of them are smart student. But for me, for my case, I think I'm lucky enough to go to the matriculation. So of course, in the matriculation, we need to compete with other students. So the things that some students learn in 3 years, we need to cover in 11 months. 11 month. Yeah, it's not even 1 year. It's 11 month, I think. So since I'm not good in mathematics, my lecturer is a mathematics lecturer, right? He asked me to drop from my study. He asked me to quit from my study just because I'm not good in maths. Just because I got B, another student in his mentor mentee program got A. No, I'm not sure, but I'm one of the student who got B plus if I'm not mistaken. So I got B plus in my maths. He asked me to quit from my study. So maybe some of you, when you listen or when you hear this story, this is like nothing to you. But can you imagine? I was like just 18 years old girl. I was like very, I'm not say innocent, but yeah, I just finished my SPM. Then my lecturer, the one who should advise me to keep on studying, asked me to drop or to quit from study. So last time I feel no. My point here is whatever you guys good, maybe some of you are good in certain subject, but if there's lecture or if there's anyone, shouldn't be a lecture actually, if there's anyone ask you to stop doing from whatever you think you should do, you don't listen to them. If I listen to my lecturer, the one that who should advise me to study, just because I got B, he didn't check my chemistry, he didn't check my physics, he didn't check my computer science. Only because of I got B, he asked me to stop studying, who quit studying. He said that I don't. He it's not exactly, but he said that I have no future in academic. So if I listen to him when I was 18, then I won't achieve what I have today. So my point here is if you think that you're good in anything and then someone asks you to stop doing whatever you're doing, just ignore them. I'm not sure where's that lecturer now, but if I can see him, I will tell him, sir, I doing my PhD when I was 25. If I listened to you years ago, I won't be here today. Okay, so that's my point. It's not only in study, in whatever you do. You just, of course, there will be a lot of people who will trying to demotivate you. Yes, there is. I think should be research on that. Girls are better in bio and boys are better in physics generally. I agree with this statement. Girls love to read. Okay. So back to my point just now, do whatever you think you like. Don't be affected because of others' word. Even your lecturer sometimes. That is a fact, okay? Like me. I didn't listen to him. I'm not sure where is him now. So now back to this lecture. Back to this lecture. So this is the three and four layers tiers between or software architecture. So as you can see here, there's 3 layer and 4 layer here. So here we have the first one is presentation. And then we have the next layer, which is business logic. So business logic, this is the difference with the 4 layers, which split they will split into another 2 layer, which is application logic and domain. So this one is for 3 and this one is 4 layers. So this is different. And then database. Okay, so business logic layer can be split into 2 layers. Okay, business logic. business logic level can be split into two layers, which is application logic and domain logic. So domain layer is used when several applications share one domain layer. It will be used when the objects physically distributed. So what is application logic? So application logic usually it is the technical specification, while domain is the targeted subject. So here they split into, from this business logic, they split into application logic and domain logic. Application logic is the technical specification, while domain is the targeted subject. Okay, this one is for, and then the last one is database. So here is the difference between 3 and 4 layers software architecture. Okay, here 3 and example. This is a case study, case example. A get boundary, a get control, a get domain, and a get database. If you check this one with the previous one, previous slide just now, this one is for here, 4 layer here. But this one is the case study. Okay, so let's check. So a get boundary, SAM, and then a get control client and a get control server. So here they have two. A get control client, they can be a get control server and a get domain. So domain is the targeted subject. So these two variable here, business object and value object, is the targeted subject. Okay, but business object. Mm, get value object. Okay. No, my point is they're split into a get control server and a get domain. And in a get domain, they have this a get business object and value object. So usually this value object, it is a entity. Usually it is an entity that represent simple entity. This one is for value object that will represent simple entity whose equality is based on the entity. That's mean, yeah, it is usually represent the simple entity. And then the last layer will be a get DB. Okay, so this is the concept of 4 layer architecture based on the get case study. So here we have an explanation. Okay, 4 layer architecture apply to part in the AGET campaign management system. So here presentation application layer. Okay, so presentation layer. As you can see, a single here presentation layer, we have two subsystem, advert HCI human computer interaction subsystem and campaign cost HCI subsystem. So this one, one this presentation layer, for this one presentation layer, they have two application subsystem. Okay, and then application layer, we have advert subsystem and then campaign cost subsystem. And then we have campaign domain. So here, as you can see, a single domain layer support two application subsystem. So this one is single domain layer. So under the single domain layer, we have these two subsystem. Presentation layer, we have advert and campaign cost HCI subsystem. Same goes to application layer. Under the single application layer, under the single domain layer, we have two application subsystem. So one single domain layer have two application subsystem. Okay, loosely coupled subsystem, each delivering a single service of coherent group or of service. Okay, so here as you can see, here you can see the subsystem into one layer, and this one is the explanation. And then 4 layer architecture, like I said, this is 4 layer architecture applied to part of the AGET campaign management system. Okay, so this one is the example of the case study, previous case study in the previous slide, not 4 layer architecture for AGET campaign management system. Okay, so that is the end of, not the end of today's lecture, but that's the end of the part for layering and partitioning. So is there any question for layering and partitioning before we move to the one that I said, MVC model view controller? Any question? Celine, do you have any questions, Celine? Oh, or it's not Celine. Who's that guy? Huh? Last time. Oh, Lim Jing Min is not here. Jeremiah, do you have any question? No. So I think no question from you guys. So this one is the one that we see in our course outline earlier in our chapter, MVC, Model View Controller, Software Design Architecture. So, yeah, okay, so what is the function of MVC? So here, from the term MVC, you can see this three component: model, view, controller. So this MVC is actually a architectural pattern that separates application into three model. So this one is architectural pattern that will separate the application into three models. So we will go and look into each of the part, which is model, view, and application. So the first one is model. So model in MVC, this one is provide the central functionality of the application and is aware of its dependent view and controller components. So the keyword for model is actually this one, provide central. So provides the central functionality of the application. Okay, this one is for model. The main or the main purpose, main function of model, and it is aware of each of its dependent view and controller components. That means they are aware of the other two component, view and controller. And then next we have view, correspond to a particular style and format of presentation of information of the user. This one is more to the interface. Yeah, interface boundary. Correspond to a particular style and format of presentation of information to the user. That's mean how they deliver, or how they present the information to us, to the user. The view retrieves data from the model and updates its presentation when data has been changed in one of the other view. That's view creates associate controller. That means if there's any change from the point here, if there's any change in the view or in the our interface, if there's any change in the interface, this view model or this view function in this model will uh, perform the function. So they will change whatever the data that they receive and they will display, or they will display and present to the user. So the view creates its associate controller. So we will see what is controller and how it is related to view. So here, controller is whatever that accept the user input in the form of event that trigger the execution of operation within the model. So controller is as you can see here, is anything that accept the user. So it will accept the input, or usually no. Of course, the user will trigger any event for no, the input will of course accept or trigger any execution for the operation within the model. So that one is the function for controller. So the change, this may cause changes to the information and in turn trigger updates in all view, ensuring that they are all up to date. So this controller will return back to the view just now so that the view can display whatever the information or whatever whatever information they receive from the controller, so that they can return, they can present, they can display back to the user, as the term is human computer interaction. Okay, so that's how MVC is perform their function. And next we have, this one is not, as you can see here, propagation propagation mechanism. This one is not related. It is related to MVC, but as you can see, it is not the term in MVC here. So propagation mechanism enables the model to inform each view that the model data has changed, and as a result, the view must update itself. It is also often called the dependency mechanism. That means they will display or they will return whatever they receive. So it is called dependency mechanism because it will view whatever change they have. So that's mean, yeah, that's why it is called dependency mechanism, because whatever change they receive, they will view. Enable the model to inform each view that the model data has changed, and as a result, the view must update itself. This one is the interface part is now on the view function. The view must update itself, or the view need to update whatever the interface is. So here, model view controller, MVC software design architecture. So many software layer has been proposed to use this MVC. MVC followed common tree layering approach. It divides the code into function in different class. It divides the code into function in different class. The layering approach of MVC. Wait, okay. Let me go back to this slide. So here, model view controller software design architecture. So many software or most software has been proposed to use this MVC. Okay, to get the system or to get the application to perform well, they're using this MVC or propose using this MVC. So usually this MVC follow three common layer approach, and it divides the code three layering approach because we have four. So usually MVC will use the three layering approach, and then it divides the codes into function in different class. And the layering approach of MVC is UI, which is the view, business logic class, logic controller, and data access class, which is the model. So this is the approach that the MVC use, view, controller, and model. So the view, of course, like I said, it is the UI, what the user see at the front end, and then business logic class, the logic, the controller, the process, and data access model, the data access class, the model of the application. And then here, MVC, software design architecture. So common MVC, three layers separating the classes into, this one is, which one? The last point here just now. So this is the common layer for MVC: presentation, HCI, controller, the logic or the flow of the process, and data access layer, the model. Okay. And then it facilitates reuse. Okay, so let's see what is three and four layers tier software architecture. So this slide is the same with the one in the previous slide. It's now three and four layers of software architecture. As you can see here, we have this three level: presentation, business logic, and database. And then here also, presentation. And like I explained just now, the difference between three and four layers is business logic. Here, they separate into two more layers, which is application logic and domain. So like I already explained just now, two application logic is the technical specification, while the domain is the targeted targeted subject. And then the last layer is the DB, database. So domain layer is used when several applications share one domain layer. It will be used when the objects are physically distributed. So it will be used when there's something physically distributed. So there's one term in computer science we known as distributed system. So anyone know what is distributed system? Or here in this case, no, not this one. In this case, physically distributed. So what is maybe Noel? Do you know what is distributed system? Huh? DISC. DI. Distributed. DISTRUBETED. This. DIS. Mm, the functions are separated into different system. Separated into okay. The functions are separated into different device. So just now my question, what is distributed system? So in computer science, we have this. Guys, 1 minute. Just now, my question is distributed system. So distributed system is actually for resources sharing. So distributed system is to allow the resources sharing between the system. So here, in this term here, physically distributed, that means they have resources sharing, or they're sharing something that is, they're physically sharing something. Separated into different, the functions are separated into different device. Uh, no, I don't think this is the correct answer. It is separated, while this is contradict with the concept of distributed sharing. Okay, so physically distributed, that means they are physically sharing something. Or distributed system, like I said, a system that share the same resources. So one, two, three. So here, so here we have three layers of our software architecture, which is presentation, logic, and data. So actually, this one is too small. This one actually, if you read, this one is just like explanation, case study. So presentation layer, the topmost level of the application is the UI. Again, the one that I said, presentation, the UI, user interface, the main function of the interface is to translate task and result to something that the user can understand. So here, already explained, the function of presentation here is to translate, or what's the term? Convert, yeah, convert whatever they receive into something that the user or the human can understand. That one is for presentation. And then next we have logic layer. This layer coordinate the application, process command, makes logical decision and evaluation, and perform calculation. It is also move and process data between two surrounding layer. So this logic layer, the basic function of logic layer is to do the process, whatever the process is. For example, here, as you can see, they can process the command, make logical decision, or any evaluation, such as do any calculation. So this is the process. This is where the layer or the process will um, take place. Yeah, process anything that required before transfer to this presentation. And then next we have data tier. So here information is stored and retrieved from a DB or file system. The information is then passed back to the logic tier and for processing and then eventually back to the user. So here as you can see, we go from here. So data of course is from up here and then they send this, the user will send a request or will trigger something by using the input, and then this layer will send to this logic layer. This logic layer will perform the process, any process that is request, and then they will send to this last layer here, which is data tier. So data tier will return whatever they need back to this logic tier, and this logic tier will send back to the presentation layer tier. So that's the process of presentation logic and data tier. Physically distributed like floppy, yes, sharing something. Floppy disk, pen drive. Why I feel like, oh, this thing. No wonder. Okay, floppy disk. Yes, no wonder I am not common with this thing. This thing, what are we call last time? I forgot already. But I think nowadays, I'm not sure. Yeah, disket. Disket. Yeah, disket. Yeah, floppy disk is disket. Okay. Yes, but yeah, sharing something. Disket. For years, I haven't heard that term. Okay. So this is the process from presentation to logic, logic to data, and then data will return whatever the data layer will return whatever the data requested from the logic tier back to this level, and then this logic tier will return to this presentation tier, and then this presentation will convert whatever data they receive from logic tier to anything that is readable. Okay, so that's the process from presentation back to presentation. This one is the case study just now. Get list of all sales made last year, query, and then, okay, here is a simple process. Get sales total. So this one is the input, get sales total, and then this one is from the presentation layer at the interface. And then from the presentation layer, they will send this request to this logic tier. So this logic tier will perform the function to get list of all sales made last year. This one, they will perform all the process, okay? And then here, as you can see, this is a query. Query to request from DB. You know what is query, right? You know what is query since you already learned database. You should know what is query. Query is like for programming, we have programming language like set of instruction. For database, we have query. Query is like also a set of instruction that we tell you use in that. Yeah, query is like instruction that we write in database. So yeah, that's the function of query. It's like instruction in database. For example, simple function is like delete from table or delete from table, insert from table. What else? Delete, insert, update. That is the most common query or the most common instruction in DB. Okay, and then I think I already explained you guys too. So whoever good in DB, whoever good in writing query, we have, they have a job in our field, database analyst. Okay, database analyst to that always manage database. It's not that always manage database. I mean they manage the database. Okay, database cells, and then here from the database they return this process cells 1, 2, 3, and 4, and then they will process again before return back to this presentation. So this presentation will convert or convey the information in whatever the user can understand. Okay. So, by the way, regarding this DB just now, like I said, there's a job for this. We call as DB analyst, database analyst. So if you're not good with programming, but sometimes programmer also need to involve. It's not sometimes. Programmer will need to involve with the DB. That means they will call all the function or they will link the system with the database. So if you think that you're not good in programming, you can just stick with DB. Database is quite the query is quite easy. The query for database is quite easy. But one thing I am not really into DB is uh, I'm afraid that I will accidentally delete the whole database because there's a query for that. Delete database. That means you will delete all information. Okay. So yeah, that's my point. Database analyst. Last time I accidentally deleted one database. So that's why when dealing with database, I prefer to not to connect to the cloud DB. Instead, I will only perform any query on my local. So whatever query I done, it won't affect the database. Okay. So here, key user action, application action. Mm, this one is like the flow, actually, the flow of the process. The flow of the process. Yeah. Here is not this point is not related to the previous slide, but this is like I don't know, maybe for the process. So here this is the key user action and application action. Okay, user action browser at welcome screen. So this is the level that related view. User points browser at welcome screen. Controller receive root URL request return welcome view. Actually, this is only for us to read. Controller receive root URL request return welcome. This is at the view layer. And then user click a button to log in. So this one is the event trigger input from the user. And then controller receive welcome request. So the input they will take as a request and they will present the login. So this one also at the interface view layer. So user supplies UID and password. Click button to authenticate. Controller receive login request, pass control to login action. This one in model. And then controller receive response from model. Controller receive the input from model. And then controller present. Okay, controller present display context or login failure based on the response. So this one is the MVC. Model view controller. This is like a flow, like I said, this is like a flow of MVC. Sample or case study of login using the MVC architecture. Okay, this one MVC. And then any question with MVC model view controller? Actually, this is like a simple case study that explain the flow of the the flow of MVC. Noel, do you have any question? Noel Lian Lee. Noel is not here. So, Nathan, do you have any question? Wong Zi Sheng, do you have any question? Okay, so that one is for MVC, model view controller. So each of the term, each of the element in MVC have their own function. Okay, let's move to this processor allocation. Processor allocation. So allocation of a system to multiple processor. Processor allocation. Okay, processor allocation is used to measure the amount of processor resources that is available. So processor allocation is measure the amount of processor that is available. So allocation of a system to multiple processor. First application should be divided into subsystem. Okay, application should be divided into subsystem, and then estimate processing requirements for subsystem. This one, this function, no, this point is actually so that they will allocate whatever resources that's needed for only the particular subsystem, so that they can utilize that resources. So that's why they need to estimate processing requirements so that they know how to allocate so that it can be utilized. And then determine access criterion and location requirement. Identify concurrency requirement. Concurrency requirement is like, I assume you know what is concurrency, the things that happen simultaneously. So they need to, there's one term, concurrency requirement is like, what's it called? Intercept. It's not intercept. Yeah, something that intercept, the requirement that intercept each other. But they are using it. Yeah, they both need to use it for the subsystem. And then each subsystem should be allocated to an operating platform. Communication requirements between subsystems should be determined. So communication, mm, like always, I always say the system or the class or even the object, they communicate using the message. So the requirement between subsystems should be determined, and the communication infrastructure should be specified. Okay, this one is processor allocation. That means they want to allocate what is the resources that available. And then, okay, that one is only processor allocation on the one slide, which is this one. So at least you should know how to allocate the processor to a system. So summary, in this lecture, you have learned about the main aspect of system architecture, in particular what is meant by subdividing a system into layers and partition. Okay, so this is the summary. I think this chapter, like I said, it's only a concept that you need to understand. There's no like diagram, only a concept, but of course they explain the concept using a diagram, but different with previous chapter. Okay, so that one is for this chapter. And then in this chapter, they they have this review question, which is explain the MVC, model, view, and controller. So you need to explain what is the function of this MVC, and then you need to explain each of this entity. What is the function for this each entity, model, view, controller? It's all up there in the slide. And then identify the example of model, view, and controller of a car mechanism. So this is a event. It's not event. This is a situation that you need to apply this MVC concept. Okay, so this is your homework. It's not homework. This is something for you to do. Okay, any question? Rachel, do you have any question? Rachel. Ivan. I always forget Ivan. Ivan, do you have any question? Konkenshak. Do you have any question? I want to check something. So oh, oh. So one of my student, so guys, again, I just received a news. One of my students sent an application for deferment. Mm, It's too bad because already week 10. But mm, wait, guys, in your class for this tutorial group, is there any of you who is confirmed COVID case? If there is, please WhatsApp me. Okay, please inform me. Ah, it's too bad. It's already week 10. So is there any question for this for our lecture this week? Where is Noel? Noel, where are you? Why are you so silent? Because I have class. So yeah, I think for this week, oh guys, why another reason why I always ask you to, I know you guys are open book. So in exam, no one tell you to do this, but of course I know student will do this. You will open, you will search, you will Google whatever the question asks. But like I always say, at least you know what is the concept of whatever we learn, because when you go to work, this is very normal, especially for programmer, especially for programmer. They will give us a test before we can join them. During the interview, they will give us a test actually. They will give us a test. No, they will give us a test, like a test. Yeah, if you want to be a programmer, they will give you like a coding, a, a situation for us to write. Yeah, coding. Of course, they need you to do coding if you're a programmer. If you become a VA, they will give you, like I said, they will give you diagram. Maybe they will ask you, or some of the company, when you go to work, they will test your IQ. It's what we call this IQ test. So at least try to be smart a bit. Okay, don't Google everything. Here in your exam, you can get for flat, but when you go to work, you won't have time for that. They will give you a piece of paper, and then you need to answer that piece of paper from that question. Okay, last time I have this experience when I was interviewed in 2019. They give me, but that was my first experience. Usually they only ask the programming, because program I apply for program. So usually it is very normal if I encounter with a programming test. But there's one company, high demand, I don't know. They give me a IQ. Yes, I didn't know my IQ last time. Before, honestly, I thought my IQ only one digit. But then after I they got give me a test, and then I get the result. So last time 2019, I'm very sure it's different with now. I'm not that active anymore. My IQ last time was 115 or 113. I don't remember. But my point here is, again, you guys need to at least know whatever you learn. Don't Google everything. Okay, here in exam you can pass, but later when you go to work, when they have question for you, habis lah. Kena, you guys must at least know. Don't Google everything. Okay, so for your study, of course you can learn, but for IQ, not all company will give IQ test actually. But for some company, they will give IQ test. They have their own measurement. They will need to test your IQ. So yeah, IQ, I don't know how to help with IQ, but for study, that's all I can help by advising you to not to Google everything. Okay, so today we will end at chapter 9. We will proceed. I already checked chapter 10, which we should cover this week, but I already checked this chapter 10. Should be okay if we proceed next week in week 11. Okay, so by this week, you should, I expect your assignment progress this week. Okay, I expect your progress for your assignment. And then for your RM research method, I already request from the CC, because as stated in already informed with you guys too, the due date for your assignment for RM research method is in week 11. So I already request to the CC to extend, but she said cannot. So yeah, week 11. Okay. So any more question? So if you have time, you better go and maybe try to familiar with some IQ test. Maybe someone will test you in the future. I don't know too. I really had when people ask my IQ. I didn't know. I only have one digit for my IQ. By the way, any question before we dismiss? Stat diagram for our assignment. Can I stat diagram? You want to ask now or you want to ask? Can we set
Now,
appointment?
now, uh,
Can.
it's just a bit only. I'm not too sure only. Okay.
You want to share?
This one. Draw one state diagram for one of the relevant problem domain class. What does this mean actually?
Wait, let me check my note.
Okay.
Assignment. One step diagram. Can I share my screen
Oh, okay.
to Ian? This one, right? Design one. This one.
Yeah.
Relevant problem domain. Hmm. Hmm. State chart diagram for one relevant problem domain classes related. Use case scenario based on the relevant problem domain class. One relevant problem domain. Relevant problem domain classes. But which that chat is that one? This one I need to ask my CC again. I'm not confident to answer your question. But yeah, I'm not confident this one. I will respond to you. Relevant problem domain classes module. Okay, state diagram for module. And then in that module, we have one problem domain. Hmm, shouldn't be a problem. This one, guys, this one I will get back to you. I'm not confident to answer this one.
Okay.
Yeah, I'm not too confident for this one. But if you ask me, what I can explain now is from your module, there's one flow. Even I'm not confident. I will ask the CC and then I will respond to you guys today. Okay, Jonathan, Ian, and everyone.
Okay.
So here, since I already opened this one, so your assignment should be this, that. One, I think one, two, 1 to 3 more weeks, 3 to 4 more weeks. Okay, don't forget this deadline and then your presentation. Okay, I think that's all. I will ask the CC. I'm not confident with the question. Okay, Ian, any more question?
No more.
Hmm. Content check. Do you have any question? No, I think we can dismiss now. Okay, guys. Thank you.